So today we're going to do an activity. It's the IP characteristics. We're going to the instruction for this activity is read each IP characteristics, then click connectionless, best effort, and media dependent to indicate its delivery method. So for this activity, we're going to identify the characteristics of the delivery method, connectionless, best effort, media independent. And here, this in the box, this we're going to load different characteristics that will indicate one of these three delivery methods, which is connectionless, best effort, media independent. So for the first one, fiber optics, cabling, satellite, and wireless can all be used to reach same packet. Fiber optics, cabling, satellites, and wireless, it is a media, so it will belong to media independent for route for routing a packet. And next one is packet delivery is not guaranteed. Guaranteed. The best effort. It has. It doesn't care if pack if it deliver a packet, if a deliver a packet, corrupted packet, or even a packet that is out of order. So sometimes it lost packet on delivering. So packet delivery is not guaranteed. And IP characteristics. It will adjust the size of the packet sent depending on what type of network access will be used. It is a media independent. Uh, it's not guaranteed the packets will be delivered fully without error. It's best effort. And no contact is made with the destination host before sending a packet. It's connectionless because there are no contact on the destination and the source. Next is it will send a packet even if the destination host is not able to receive it. It doesn't care if it is a connectionless method, delivery method, because it doesn't care even the host is will not able to receive the packets from the source. So it's connection because it doesn't know because the it's connectionless because the destination doesn't know if the destination host doesn't know that he will going that it will going to receive a packet. That's all. And this part of the activity will go to it's activity part one. It's titled IPv4 header fields. Instruction: read each IPv4 header function and then click the IPv4 header field to which it belongs. The function, the first function is commonly referred to as hop count. Hop count. Hop count means it will go to different routers and it's belong to time to live because time to live is it's the limitation of the packet. In other words, ev- every packet that comes to a router, it will be decremented by one if it's if the time to live is equals to zero or hop count is equals to zero, then the packet will be dropped. Next one is identifies the IP address of the recipient host. So the IPv4 header fields must know the destination IP address so that it will able to send packets. Identifies the upper layer protocol to be used next. It is a protocol. Next one is identifies The IP addressing of the sending host will be the source IP address, as you can see, sending host, and the one that we're going to send is the source. Next one is identifies the priority of each packet. It is a differentiated services or type of services. Last is always set to 10, 100. Is a, I think it's a hexadecimal, it's a binary. Then always set a binary 100 for IPv4. Okay, for this activity, it's IPv6 header fields. Like the previous activity where we we uh the we answer the activity IPv4 header fields, which it's it's both IPs but different versions of of header fields. This IPv6 it is more simpler than the IPv4. The instruction is read each IPv6 header description and click the IPv6 header field to which it belongs, like the previous activity on IPv4 header field. The first IPv6 header description is always set to 4-bit binary 0110. This version is very different to uh, IPv4 because IPv4 is 4-bit binary 0100 and this is 0110. Uh, the next description is when this value reaches 0, the sender is notified that the packet was not delivered or dropped. It is a hop limit. It is same as TTL or time to live that that limits the lifetime of a packet. The next one is IP header description. The next IP header description is classifies packets for congestion control. It is in traffic class. Traffic class is same as differentiated services or type of that will prioritize the packets. Next one is identify the application type to upper layer control. It's flow label. Nope. Oh, identifies application type. The next header. Next header is it's next header because if we compare next header to the IPv4 header fields, it can be compared. It is very similar to protocols which identifies the application type to the upper layer protocol. Next description is to suggest that all packets receive the same type of handling by IPv6 router. It is in flow label. And next is identify the size of data portion. In this activity, we're going to identify the elements of a router routing table and tree. Uh, this is a This is the sample of routing table, and the instruction for this activity is a partial router routing table entry is shown. Each section of the entry is identified by a circle letter above it, which is these letters. Select the correct routing table entry section for each output. So the first one is the elapsed time since the network was discovered is letter E. So you can see it's a time. It's look like a timer. So the okay. I think I should answer this first before I explain why that was my answer. Administrative distance and metric. See, and how the network was learned by the router is A. So the destination of network is B, the IP address, and then the next hop of IP address. This IP address will occur. We're going via this route. This the outgoing interface on the router to reach the destination network is F. Okay. The elapsed time since the network was discovered was on letter E on the column E because as we can see in column E there it's look like a timer. So that's the elapsed time since the network was discovered. The number two, the administrative distance and metric for reach the remote network. Administrative distance and metric was is always with each other. Like on letter C, so you can see the administrative distance is 90 and the metric is 3072. On number three, how the network was learned by the router. It's always at front, letter A. D is for remote network. And number four shows the destination network is the IP address. And number five, the next hop IP address to reach the remote network is to the it will going to hop to the router via the IP address of the router. The outgoing interface of the router to reach the destination is through the physical port gigabit Ethernet 0/0. Okay, on this activity we're, we're going to know the description of router functions and hardware parts. Instructions for this activity's description of router functions and hardware parts are provided in the table. Drag each router component name to its function or description. The first is it connects routers to external networks, usually over large distance. We all know that one wide area network will able to connect large large distance uh, over large distance. So one interface will connect is the one who will connect the router's external network, usually over a large distance. Uh, the next description is a way to remotely access the CLI across the network interface. If we are going to access the CLI across the network, we are able to use Telnet or SSH applications. Next is it connects computer switches and router for internal networking. Internal networking means I think it means a small geographic area like a house, like that. LAN interface will do the thing. Next description is a local port with USB or low-speed serial connection to manage network devices. It is a console port. As we can see, if we try to configure a switch using computer, if we configure initialize the switch we're going to need to console cable that we're going to connect to uh, the console port. Next is a port to manage routers using telephone lines and modems. AUX port is on telephone lines and modem. Check. It's correct. It's all correct. On this activity, we're going. This is entitled Router Boot Process. It's all about how router boots itself. So the instruction for this activity is drag each of the steps on the left to appropriate field in the table on the right to show the router boot process in order. Now, the step one, when the router boots up, it will going to perform post. Uh, it will going to check the hardware performed by ROM. And we're going to check RAM and VRAM, CPU, and other hardware inside the router. Next, after performing post, the bootstrap will load. It will, the bootstrap will be copied from ROM to RAM. After bootstrap was copied, it will going to locate the iOS. The next one is load the iOS. Load the iOS. The router will load the iOS its iOS file, its operating system file na na that that was on RAM after bootstrap. Next one is load the configuration file from flash from NVRAM, a TFTP server, or go into setup mode to create configuration file. Based on what I've understand on how the router boot process, uh, if the bootstrap if the router cannot load can or cannot find the iOS, it will going to load the TFTP to find the iOS on the network. Like on the last process, the load the configuration file from Flash and VRAM a TFT server or go into setup mode. It includes TFT server because if it can't load the configuration file from the NVRAM, which is saved on the startup, it will going to the TFTP server to find the configuration, or if it has no configuration at all, it will go into setup mode to create a configuration file.